All right. Hello and welcome. Tonight we're going to do something a little different. I'm a member of various web forums and Facebook groups that pertain to audio-related things, and I saw a posting on there, and the posting was questioning the quality of specifically KLIPSCH amplifiers, recent KLIPSCH amplifiers, and that prompted me to make a posting on there, and the posting seemed to get plenty of comments, some in favor, some against, which is fine. But I wanted to go in depth and talk about standby mode on newer amplifier and older, I guess, amplifiers, and why you shouldn't always rely on that to turn your amp off. So let's get into it. Let's see what we got. So I have a sub 10 plate amp, and these are a few years old. I don't know exactly when they were made. I could look it up. There's not a date code on there, but you can see by the little sticker in the corner here that they're made in China. So at some point, KLIPSCH outsourced their amplifier designs. They went to Indigo, which is Bash, and I believe that was a Canadian company who is now owned by Sonovox, I think. But the amps were outsourced, and whoever they purchased the amps from, has them manufactured wherever they can get, good prices and cheap labor. One of the problems with that, though, is when you have, amps that are being made cheaper, they use cheap components. Now, this amp has been partially redone. I took most of the glue off, which we'll get into. I replaced, all the capacitors on there, and repaired any damage. You can see right here, this is a sub 12. Sub 12 has the larger square transformer. Sub 10 has the smaller vertical transformer. But we'll get into that. So the quality of the parts, is a concern. And then the way that the amp is assembled is also a concern. So let's talk about the problems first before we even get into the standby. So most amplifiers that are manufactured, in the last, I would say, 10 to 20 years, used some kind of glue on them, and it's this stuff here. It's like a hard yellow rubbery glue. And let me zoom in here. So this stuff here, it's a very strong, hard, rubbery glue, and it's not bad stuff. But the problem is when it gets exposed to heat, it dries out and it turns this nasty brown color, and it gets kind of like crunchy and crusty. And when it gets to this stage here, the glue becomes electrically conductive. So you can see they have a capacitor being held onto the board. They have high voltage DC going, right underneath here, and then it's touching all these little pins that are on all these surface mounted parts. Well, when this becomes conductive, if you have a high potential on one side and a low potential on the other, these things start to short out, and eventually they burn, or they blow the board, or they do all kinds of damage. Now, I have an amp here. This is a JBL 8400, I believe. You can see right through the board. It literally burned a hole through the board. Now, that's a combination of glue and electrolyte. And I have prepped and cleaned this board. I'm actually going to rebuild this. I'm not doing it for a customer. We both decided that it would be too much, work and too much expense. But you can see that same glue used on a JBL amp, and it's crusty and becoming conductive. And luckily there were no shorts over here. But this, this part of the board is completely destroyed. Really this amp should be thrown away and not redone, but I'm going to redo it anyways just for fun. So the glue is one problem, and the glue is related to heat. And when these amplifiers are put into, quote unquote standby mode, they want you to believe that they're powered off, or whatever they want you to believe, but they're not fully powered off, not all of them anyways. So The Synergy series CLIPSCH amps, the sub 10, sub 12, and I think the RPW is part of that series. If not, they use the same exact amps inside the RPWs, but they get hot. So you have these large resistors here. These are current sensing resistors. They get hot when the amp is functioning. You have these two resistors here, which are also current sensing and limiting resistors that feed the power to the outputs. And then you have these two voltage regulators here. So those components are the really hot components. They get screaming hot. And the diode bridge gets pretty warm too, as well as this control board. So you have all this glue, that's smothered all over these parts. And they're continuously just being cooked by this heat. And so this amplifier, when you put it into standby mode, and I'm not going to pull up the schematic. I feel like I can explain it good enough. So you have volume controls on the back of this plate, your controls here. And they have this little cable that feeds the board. One of the wires on this cable, let me get this into view here a little better, zoom back out. So the volume controls, feed signals back to this cable. So two of these lines are plus minus 15 volts. One's ground, one's an audio signal, and one is for the on-off. So this board senses the audio signal, and it controls whether or not the amp goes into standby, and that's based on the switch that's on the back, auto or on. This one doesn't even have an off function, just auto or on. When you leave it in auto, all that this does is it tells this transistor right here to either mute or unmute the audio signal. And the way that it does that is it just takes the audio signal and it dumps it to ground. So it puts a dead short on the audio output to ground, essentially muting the speaker. And the power supply, since it tracks the level of the audio signal, puts the outputs into the lowest power that they can draw, low idle current. But these two voltage regulators are still on. They get screaming hot, and from the factory, they're positioned up and right next to these capacitors, and they just sit there and they just boil the caps. So your capacitors are being cooked slowly, and granted, some people are lucky, and theirs are, I've bent these, but theirs are, spaced far enough apart. Some people are unlucky, and they're sitting like that, and they're just right up against the caps and just cooking them. So you have to understand how this works and why I'm giving this warning, that you should unplug your amps. If you have money and you don't care, you want to leave your amp plugged in, and if it blows up, you throw it out and get a new one, hey, that's great. If you want your equipment to last and you want to be a little bit of frugal, I highly recommend, if your amp has a switch, just go back there and do this. This is all you got to do. Watch. Do that every time you use your amp, and do that every time you aren't using it. And even this plate, with all the defects and all the issues on it, will last 15 to 20 years. I know it's a nuisance, and some people don't want to go through that effort to do it. Buy a smart plug, buy a Wi-Fi controlled outlet, put a power strip in there, hook it up to a light switch, however you want to do it, just make sure you switch the amps off. So, I know I said I'm not going to pull up the schematics, but what I am going to do is I'll just show you. And I apologize because my desk is just a disaster of a mess, and I'm hitting buttons that I shouldn't be hitting here. Let's zoom back in so we can see what's going on. You don't need to see me in my pajama pants. So this is my little book of CLIPSCH secrets. There's some schematics, there's some drawings that I made. A lot of different stuff in there. I'm just going to specifically pull out the sub 10 and sub 12 related stuff because I know that is readily available out on the interwebs if you search hard enough for it. But I've worked on these so many times I don't even really need to look at them anymore. I kind of know what goes where, so let's see. That is the audio side. This is just a block diagram. That's the second side of the output. Just bear with me while I look for this muting section. There's the LED. Alright, here's page 1 of the on-off. So the rest of it I'm hoping is in this group. On-off. Yeah, here we go. Here's what happens. So the audio control, we're going to come in a little bit tighter. And of course it'll be a little bit blurry. So this is the control signal that comes in from the preamp board. And it goes through these circuits. I'm not going to explain what they do. And then it goes to this on-off portion here. And that on-off portion gets coupled with the audio output. So here's the audio output, and this is what eventually goes, and it goes to the amplifiers that drive the speakers. So right before you get to the this is either high or low pass filter. I can't remember which one that is. But right before you get to the filtering that goes to the amplifier, you get right here. And your audio signal is present at this point. When the amp goes into auto standby mode, all that circuit does is it turns this transistor on, and it takes your audio signal and just dumps it right to ground. That is the only thing that standby mode does. It mutes the audio signal and puts the rest of the system into a lower powered state. It doesn't put it into a standby. It doesn't shut anything down. It's just constantly running. So just an explanation of how it works. And the problem is cheap components are used. I can't get my folder back there. Alright. So the capacitors that are used on this guy and this guy haven't worked. And of course the stuff is burned off. This is a DM capacitor. It's labeled DM with a circle on it. And I can't really get that in there because this board's in the way. I don't know what DM is, but what I do know is that this is not on the Tier 1, Tier 2, or Tier 3 capacitor list. So this is just the cheapest capacitor you can get, made by some random company. And DM might also be the series of the cap, but even so, I know these are not quality caps because I've looked them up. This one, this one does have a name on it. It's a Yecon. Never heard of Yecon. So you can, if you look at the label on the side there, you can see the name on it, Yecon. It's not known for being a quality capacitor that's going to last. Something that's in a piece of audio equipment that's, several $1,000s is going to use a lot different caps. They're going to use Nichicons, Rubicons, Cornell Dublier, Panasonic, any of the Tier 1, maybe Tier 2 capacitors. So if you have the better capacitors, they do better with the heat and the components last longer. So, when you're buying a cheaper system, a budget system, they might sound great. It might work perfectly fine with your system and the setup that you have, but you have to account for the fact that there's going to be subpar components installed on the inside. If you're handy, you're tech savvy, you can go in and replace them, and you can turn a cheap amp into a very, very nice amp. Now it's not going to affect sound quality. You're really not going to benefit except for increasing the life of the piece that you're working on. So that's the basics on it. And I want to go through some of the other issues that are CLIPSCH related. Maybe we'll even get into Sunfire because I have a couple Sunfire plates just sitting right in front of me. But the newest beast that seems to be causing all the issues in the CLIPSCH world is this guy here, or these guys, the R series amplifiers. So 115 SW, 112, 110. These are like the newer reference series. This one did some rework on. You know, they use cheap switches. If you bump these switches, the switches snap right off, and these are not replaceable. I cannot replace these switches without spending a ton of time and labor. So what I do now, I took one out and I just said it's not worth it. You know, it's just too much messing around. I hard position the switches into the position that I want to put them in, and they are disabled. So this one is set in phase 0 and on mode permanently. There is no auto or off. But the interesting thing is these amps, the auto function actually does work. So there are some exceptions. On this power supply, they have an auxiliary transformer down here. And this auxiliary transformer feeds 5 volts into the amp board. And that amp board has the auto sensing circuits on it. So when the switch is in auto, it senses whether or not there's an audio signal present, and then it turns on this whole side of the power supply, and the powers up the all the electronics on the amp board. So this is one case where KLIPSCH tried to get it right, and they're like 90% there. They almost got it. The standby circuit actually does place it into an ultra low power mode. It has a housekeeping supply, the 5 volts, which shuts everything down. So the only thing that you really have to worry about are these 2 caps here that are part of that low voltage supply going bad, and maybe a few other components on the board. But this is going to last a very long time. The power supplies on these are fairly good quality. They use silicone glue on it. They don't use that nasty yellow glue. But when you get to the amp board, we're back to having the garbage yellow glue, and they put a resistor on these. And I don't know, yeah, here's one. Remember what I was telling you about the glue and heat and being on. So here's that glue on the board. Let's see if I can get a little more light. You can see down in there that this yellow glue is starting to get a little bit brown. In some of these other places it's getting more brown. And then you look at this resistor. Let's unplug these so we can get a better view. You look at oh, I just noticed that. Somebody just cut the speaker wires off. Whoops. You look at this resistor down in here, and you can see that there's some green stuff in here that it started getting conductive and eating into this wire, and then it's just covered in black like soot, and some of the ceramics burned off, and this was covered in glue. It got hot. The glue starts to become conductive. Now luckily this one doesn't have too much glue on the main board, but this whole area just gets extremely hot. On some of them, I've seen them where it actually damages the board. You can see that, around these capacitors, it's really dark and brown and nasty. And, we're at the point now where we're getting close to risking shorting out this board. On top of that, these 3 capacitors, this one here, and this one here, are most likely well out of spec. So if you have an R11X series amp, and it's clicking off, it's making noises, it's thumping, it's doing what it's not supposed to do, this capacitor, this one, and this one need to be replaced. 5 capacitors, and you should replace the resistor. So KLIPSCH at some point realized that they were making a mistake. They figured out, probably through warranty claims or some other reason, that they were having issues. And their solution to that was, let's take this resistor out that gets hot, and let's put one of these in there. And this is just a 10 watt large ceramic resistor. So they stuffed that guy in there, and they made no other changes. Well, that's great. Actually, they did make one other change. They went from this nasty conductive glue to silicone glue. So they almost made it, safe. Problem is this amp sits inside of the sub like this. This is the top side. Well, when you have a resistor there, it doesn't really matter what wattage the resistor is. If you're pumping, 3 watts of power through that resistor and it's getting hot, 3 watts are going to still go through this. 3 watts is 3 watts, so it's going to put out the same amount of heat. If it's putting out 3 watts of heat in the small resistor, it's going to put out 3 watts of heat in the bigger resistor. They didn't change the value is exactly the same. But the problem is the plate sits like this. So this resistor is sitting underneath this board here, and it's getting hot. Well, hot air wants to rise. Well, the hot air has nowhere to go except to wash over the bottom of the board, and the heat gets trapped under here, so you have a hot spot, and it's still, even with the upgraded resistor and the better glue, it still cooks the capacitors. And I have a bunch of these new amps that have bad caps that don't work because they didn't address the problem. So my solution, my new solution, and this was based off of a recommendation of one of my YouTube followers. So why don't you just move the resistor to the other side of the board where it's out of the way and it doesn't trap the heat? And that's what I do now on all of my repair. I use a 5 watt, actually, no, this is a 5 watt. I use a 5 watt resistor. And I just put it on top of the board, and then I put a little dab of silicone in here to keep it from bouncing around. And all the heat now, you get a little bit of radiant heat that radiates down to the board, but most of the heat is free to travel up. And, you know, you get a little bit of air coming underneath the resistor and some air going up. So when the sub is actually on and moving, you get a little bit of airflow in the box, and that kind of helps, you know, keep the temperature down. But when it's in standby mode, this is all off, and you don't have to worry about it. So you're not trapping heat, you're not cooking your capacitors. So, you know, these amps with a small rework should last a pretty long time. But I wanted to show the difference between the two. So if you have like the newer style sub and it has the auto feature on it, you can use the auto feature because it actually does work. On the older gear, not so much. You know, the JBL, they did the same thing. They didn't kill the power supply. They just have a relay on the board, and that relay controls the output. Well, that doesn't really do us a whole lot of good if we're trying to save the power supply and the capacitors. This is a Super Junior amp from a Sunfire, and same thing. It just the power supplies do not shut down, and they just get hot. And these also have cheap caps in them, and you can see on this board down here, there's some soot and burning and you know, whatever. These coils get hot. These inductors. It's sitting right next to this, you know, large power filter cap, and you can see both of them. This one's bulged on the top, and this one let loose, and it just burned out the bottom of the board. You can see the electrolyte leaked out of it. Cheap capacitors and heat, and there's a trend there. You know, Sunfire is not a cheap company, cheap subs, but you know, when they took their business over to China and they started using cheaper components, heat and cheap capacitors, no good. It's bad news. And if you mix that with conductive glue, you're going to run into problems. Let me see what else I have in my box here. I don't want to drag this on too long, but I figured I'll give as many examples as I can with the pieces and parts that I have, you know, sitting in front of me. What's this here? RW10D. This one I salvaged a power supply out of for something. But you know, you can see on this amp, it's got that glue on it. Now, in the areas where there's no heat, the glue still stays nice and yellow. It doesn't start to deteriorate. You can see over there by the audio input jacks, it's still nice and yellow. You know, anywhere where there's no heat and no voltage, the glue behaves itself. You know, even on the actual amplifier board here, it's on these two pots that adjust the bias, and you know, it hasn't started turning brown because it's out of the high heat area. The resistors are well out of the way of where the heat gets drawn, and then, you know, there's nothing down here by the actual output FETs that would cause that glue to turn. So it depends on how the amps were constructed. These have their own set of problems. The power supplies, are covered in that glue. They get hot, and same problems. You have failing capacitors and failing glue. Now these amps, they have, well, this is the digital version, but on the digital version, it has that same standby feature. Well, the power supply is always on. It's always supplying to this board, plus and minus 15 volts, and that goes through these two guys right here, these two regulators, which get extremely hot. And then it has a constant 8 volts out that powers the amp section of the board. When the audio signal is detected, that 8 volts starts to rise, and the louder the input signal is, the higher the voltage that goes to the output board. So it's a tracking supply. That's how they get it to be class D or H or whatever they call it. But it doesn't go into standby mode. It doesn't shut off. So you have these Junzel capacitors right next to these, voltage regulators, and eventually they fail. 90% of these amps that I get in here to look at, I have to, without even touching them, I have to replace all these caps here because they're either, well out of tolerance, or they're on the verge of going bad. So it's unfortunate, but they're done that way to save cost, and I think some of them are just some design flaws. Like these newer 112 and 115 SWs, they really almost nailed it. They were close, but just moving in. To be honest, this resistor shouldn't be there. The power supply should have been a switching supply. It would have taken up a little bit more real estate on the board. They probably would have had to make this board a little bit bigger. They could put a small switching power supply on here to feed the amplifier control chip, and at the expense of a few more dollars, could have made this a very robust amp that would have never had any problems. But those few extra dollars add up when you're selling a million subs, or however many of these subs they sell. So for whatever reason, they didn't do it. They were almost there. But with a little work, you can make this a great amp. So for what it's worth, I figured, we'll go through, and I can just give you guys a little bit of overview, what I see, what I know, how to keep your amp working, and how to make it survive and last a long time. Like, you don't want this. You don't want to end up with this. This is, for the most part, garbage. And this will happen to your KLIPSCH amp. It'll happen to your, your JBL. It'll happen to your Velodyne. I have Velodyne amps. I have Sunfire amps. Like, it's always the same problem. Heat and glue. Heat and glue. So turn your amps off. Buy a switch. Buy a smart plug. Buy something to make sure that you can shut these things off. Get the power killed to them when you're not using them. And not only that, it saves on your electric bill, 5 or 10 watts sitting idle for years and years and years, that adds up, It's a nice steak dinner after, years and years of sitting idle. Why not? For the extra 10 steps and 30 seconds it takes to flip a switch or to hit a button on your cell phone, it's, in my opinion, well worth it. So I hope you guys learned something from this. Feel free to ask me any questions. I can try and give some more examples. For what it's worth, switch your amps off, save your capacitors, and hope you guys have a good night. Thanks for tuning in.